Hello, welcome back to PhysioDesigner tutorial series. In this tutorial, we will introduce the Flint, a simulator of models written in PHML and SBML. It can also parse SBML, PHML hybrid models. Flint was already used in the previous tutorials. Here, not only basic usage, but also some convenient functions are demonstrated. Moreover, at the last part of this tutorial, we will introduce another application called phplotter, which is a graph plotter supporting the data file format used in Flint, as well as regular CSV format, and is freely downloadable from physiom.jp. Alright, we will begin with a very simple case. First of all, open a PHZ model file, which is created on PhysioDesigner. Here, we'll use one of models in the sample directory, which is bundled in a PhysioDesigner package. The name is coupled hhmodel.phz. This is a model of two neurons connected by a gap junction. Each neuron is modeled by Hodgkin-Huxley model. In the main window, you can select the algorithm of numerical integration. For now, two algorithms are implemented. One is Euler method, and the other is the fourth-order Untitled method. The second parameter is the simulation length. Let's set 150 milliseconds here. And the third parameter is the time step for the numerical integration. The parameter in the output box defines the sampling frequency. If we set it 10 steps, it means that one data point in every 10 steps is dumped in the result file. So if you want to reduce the result file size, it is better to put large number here. Okay. This is the minimum settings for executing a simulation. Click Run button at right bottom of the window to start a simulation. The progress is shown by the progress bar. Wait for a while. When the simulation is completed, a notification dialog pops up. Click OK button. To view the graphs, click Detail button and View button. A simple graph window pops up. There is a variable list in the leftmost box. To draw a graph of one of variables, select one variable, drag it to the left axis box and drop it. It is possible to put multiple variables in one axis box. Here let's observe V1 and V2. Every time the first neuron makes spike, the second neuron makes spikes as well, because the membrane potential of the first neuron was transmitted to the second neuron through the gap junction, triggering the second neuron spike. Now let's plot INA as well, whose range is very different from V1 and V2. If the y-axis scale of the variables is different very much, it is better to plot some variables using the second y-axis, that is right axis. To move a variable from left to right, it is again just drag it and drop in the y2 axis box. When you don't need to observe a graph of a variable anymore, just drag it back and drop it in the leftmost list box, where originally it was. Then the corresponding graph disappear. One of convenient functions of Flint is enabling users to copy the figure of the graph on the clipboard, so that users can paste it on some other applications to take a note. Right-click on the central graph pane, and select Copy in the menu. Of course, it is also possible to save the figure in a file. Select Save As in the same menu instead of Copy. On the center graph pane, it is possible to zoom into a selected part and zoom out. There are two ways to save the simulation data file. One is in ISD format, which is a binary format defined in Flint. The other is CSV format, which is a regular text format, and values are separated by comma. Clicking Export as ISD button pops up a dialog in which users can specify a file name to save. There is a plotter application freely available at physiom.jp, which can read both of ISD and CSV data created by Flint. We will see how to use the plotter later in this tutorial briefly. Alright, so far we reviewed basic usage of Flint. Flint can do more. If you want to try simulations with different parameter values, you can do it here. Go to Parameter tab on the main window, and double-click at the cell where you want to change the value. Here change the value of the conductance of the gap junction. That's it. Next time you click Run button to execute a simulation, the new values are used in the computation. Next, you can select variable to be dumped in a simulation result file. It is possible to use regular expressions to narrow down the variable list. Okay, now let's observe the dynamics of the model with the new parameter value. Click Run button, and open the graph dialog. Now you see, in the leftmost box, there are only 5 variables. Move the variable V1 and V2 to the left axis box, and stimulus current to the right axis box. Because of the changing the parameter value of the gap junction, the dynamics of the second neuron was changed, and now it makes only 2 spikes, while the first neuron makes 5 spikes. Previously we changed the value of a single parameter, but it must be convenient if a set of parameter values can be defined, and multiple simulations run automatically using the values in the list one after the other. Yes, Flint can do. In this example, we consider 2 variables. One is the conductance of the gap junction, and the other is the frequency of the stimulus current pulse. To define the value sets, click Define Value Set button. A dialog pops up. On the dialog, first of all, set the name of a parameter. Any name is okay here. There are 2 ways to define the value set, that is enum mode and interval mode. Firstly, select interval, and set the lower and upper boundary of the range and step. Then automatically values starting from the lower boundary, and increment with the step unto the upper boundary are generated. This value set is referred by the parameter name, which is PG in this case. To add a new parameter, click plus button. The second parameter is pfreq, in this example. This time, let's set values in enum mode. In this case, just enumerate values in the text box separating with comma. Okay, that's all for defining value sets. Next, we need to modify the parameter values using the value sets now we defined. We use the name of the value sets, and set it at the cell in which value is defined. Double-click the cell, and put a parameter name, such as PG and pfreq, in this example. Then, click Run button to start simulations. This time, because there are 4 values in PG, and 3 values in pfreq, hence in total 12 simulations run automatically with taking all combination of the parameter values. The simulation progresses can be seen with progress bars for every simulation, or, clicking Chart tab, the simulations are shown as points on the parameter plane. Progresses are displayed by filling circles. Once all simulations are completed, a notice pops up. To view a graph of each simulation result, select one of simulations. Parameter values used in a simulation are written up beneath the progress bar on left side. Finding the simulation you want to observe, click View button just beneath the progress bar on right side. Then a graph dialog pops up, and you can observe the graphs. Similarly, on the parameter charts, double-clicking on a circle pops up the graph dialog. To save all simulation results at once, click Export All button. Specify a directory or create new directory. Flint saves all simulation results separately in the directory. Hence in this case, you will have 12 files. The correspondence between parameter values and simulation result files is described in simulation.txt file. The graphs of the simulation data in those files can be drawn by phplotter. It can load multiple data files of ISD and CSV formats. To load files, click Add button at Data File field, and select Data Files in the dialog. To draw graph, at first select one file in the Data File field. Then variables included in the file are listed in the Variable field. Look for a variable in the list, and tick a checkbox at the left side of the variable name. Then the graph of the variable is drawn in the main panel below. You can tick several checkboxes, considering the y-axis scale of the variables. If you want to plot a graph using the right y-axis, tick the checkbox at right side of the variable name, and reset the scale from the context menu popping up by the right click on the panel. Now let's plot only the stimulus current, but in the all simulation results files. Untick the checkboxes of V1 and V2. Then now you see only one graph of the stimulus current on the panel. Now click Apply Checks for All Data Files button. Then, if, in other data files, there are the variables with the same name with the currently ticked variables, all of them are also ticked. There are 3 curves, because we used 3 values for the stimulus frequency in the bunch of simulations. To remove all ticks, click Clear All Checks button. Finally, we show a little bit tips of phplotter to change the curves property. Plot 2 graphs. Any of variables are OK now, and select Preferences from the menu. Go to Line tab in the dialog, then select Variable's name in the combo box. Here you can set line type and thickness, point type and size, and color. If you apply the settings to all variables, not to individual variable one by one, for example, if you want to set the line thickness to all variables, set to it first, and click Apply to All button. Then click Apply button at the bottom left of the dialog. The graphs in the main graph panel are updated. You can change the color and line type as well. Alright, this tutorial finishes here. Thank you very much for listening. Goodbye till next time.